Hi guys, welcome back to my channel. This is today's topic, welding inspection, the defects repair. This is the part 2. Part 1 already I have uploaded and you have to continue this video for part 2 because the part 1 it was not completed for the so many defects are there. That's why in one video it was not completed. So you can see this defect in the second video. So this is the part 2. This video actually will be explain undercut, extrude penetration, burn through, caterpillar, linear misalignment. This will be the discuss for the today's discussion in welding inspection defects. So let's start. So we will discuss first undercut. What is undercut? An irregular groove at the toe of a weld run in the parent metal. You understand this is two joints. One is the fillet joint, another is the groove joint. What it means in an irregular groove? You can say this is the groove, but at the toe, this is coming downside, means the parent metal has been melted already. So this is called the irregular groove at the toe of a weld run in the parent metal. So when the welder has done the welding or welder is doing the welding, that time you can see because of the amperage is too high, that's why it is melted the parent metal. That's why the undercut has been created. So this is called the undercut in the fillet weld. In the same way, you can see in the groove weld, the toe portion at the end portion, the coming downside, the parent metal already lost. So that is called the undercut. So undercut, why it is happen? What is the reason? First thing is excessive amperes. Just I have told amperes and voltage. If it is excessive, definitely undercut will be created there. Excessive travel speed. If you see the travel speed is more, it is not as per the WPS. Definitely the undercut will be created. Incorrect electrode angle. Electrode angle as per WPS, if you see the 35 or 15 degree to 25 degree is mentioned, whatever is mentioned in the WPS, you have to follow that one because that WPS is created through the PQR. As per the PQR, then we have to make the final WPS. That's why you have to make the incorrect electrode angle. So what is correct electrode angle? Where you can find out? You can find out also from manufacturer recommendation. Excessive weaving. You see the excessive weaving. It is not required. Some weaving it's coming like that is weaving. If you see weaving is more than that. So definitely the excessive weaving is comes under the parent metal. So it can be created the undercut. Incorrect welding technique. If it is welding technique is different. If you this is SMW welding, so you have done the some electric welding technique is different. Means characteristics, current, amperage, voltage. The welding technique is different. Definitely the undercut could be appear. Last is electrode too large. If it is electrode too large, definitely the undercut could be created. So you understand first what is undercut and what is the reason of the undercut can be created here. Now we'll go for cap undercut, the visually how it looks like. You can see it's very clear. You see this is your welding capping, but you see this area has not melted. This is can be two things. One thing is parent metal is melted and after that this undercut has been created, or the parent metal has not been melted. So this also undercut also melted if it is happened, this also undercut. So this is undercut, this is undercut. You understand here how it is. This is the your line, the parent metal line is here, but the for the excessive current the material has been melted in parent metal. So the undercut has been appeared here. So you have to mention this one, you have to measure that one. In a TWS CSWIP exam, what is the length and what is the depth of the undercut? This is very important. Undercut means there is the acceptable limit. All undercut is not like that rejected. So there is the acceptance criteria. You have to understand that acceptance criteria. You have to take from the CSWIP when they will given one paper that is mentioned there what is the acceptance criteria. That acceptance criteria we have to prefer. So this is two things. One is the length, one is the depth. You have to measure for the each undercut. Now the undercut RT images how it is looks like. You see undercut here in the root undercut. You see here the root undercut. Root undercut. You see the one side. The one side is okay. This side is okay. There is no problem. So this image is okay. But another side you can see from here to here, that area there is the undercut, means not full length of the weld from here to here, that area only the root undercut is there. So the image is coming like that way. You can understand here this is root undercut, and you see there is the capping, there is undercut is here. So you can see the images is the density is something different from here to here. The undercut is can be undercut images, it would be like this way. From here to here, this is the capping undercut. So you understand the root undercut and the capping undercut. There's a two different undercut. It's here images. Now shrinkage groove. What is mean by shrinkage groove? A shallow groove caused by contraction in the weld metal along each side of the penetration bead. Means when you are doing the root welding, in the root welding at the time there is, you can see the groove has been shrinkage in this way. Why it is happened? The shrinkage in the inside. Why it is happened? First things cause the insufficient weld metal deposited in the wood pass. If you see the root gap is more or root gap is less, some weld metal is insufficient to melt at the groove, this root gap. So that's why the coming is shrinkage groove is coming. Insufficient weld metal, definitely. Why it is coming the inside? The insufficient weld metal will be, when it will be deposited after the cooling, then it will becomes inside, because there is not sufficient weld metal. If the cooling, when it will be cooling, there will be shrinkage. That's why it comes inside. Second, what will happen? Too fast a cooling rate during the application of the root bead pass. That's why I discussed now. Cooling rate is too fast. When you are doing welding, if you see the cooling rate is too fast, means your travel speed is very fast. Travel speed is very fast. That's why the fast is cooling rate. That's why the root bead will become the shrinkage. Poor welding technique. If its technique is very bad, definitely this is all. This term, poor welding technique, this term will be applicable for the all types of defect. You have to remember that one. So you understand the shrinkage group. Now, concave root. What is concave root? A shallow groove which may occur in the root of a butt weld. Concave, you see, the root is how it's coming. It's like that after finishing the weld. So you have to know why it is coming. Root faces too large. If you see the root faces is too large, not as per the WPS or not as per the drawing, you can see there the concave root will be appeared there. Root gap too large, root faces too large, or root gap also too large. These things can be happen. Excessive back part pressure during TIG welding. So there is a part pressure when during the TIG welding. So that part pressure should be as per the WPS. If you see there is some problem in the part pressure, back part pressure is more than that, definitely in that pressure it will become the concave root. So you have to follow that back part pressure. It will be as per the WPS. excessive root bead grinding before the application of the second pass. What will happen? The first run you have completed in the root. In the root, first run you have completed. After that, you have grind it. You think that there is some problem in the root, so you grind it. And at the time of grinding, there is some more grind. There is some material more grinded. Means material is removed. Some old material. So what will happen? And the next run, when it will be melted, and when it will be melted at the time of hot it was, and when it will be cooling the second run, that time it will be shrinkage, so it will become upside. So that's why excessive root bead grinding before the application of the second pass. Now concave root, how it looks like, you see the concave, how it looks like. This is your concave root from here to here. You see it's not coming on the same level, it is coming inside. You understand here how it looks like from here to here. This is your concave root. Now excessive root penetration, that was concave root. Now root penetration bead in excess in accordance with the relevant specification being used. You see, as per WPS, there is the root penetration is there, and what is the root penetration bead will be more than the parent metal height. So it is mentioned in the WPS or the as per the drawing. So we have to follow that one. But it is root penetration is excess. Why it is excess? You see, it is 1.5 to TMM is okay, is a normal practice. But you can see here, it's too much, excessive root penetration. So it is root faces too small. Root face, you see the root face is very small. It is not, you cannot see here because it is penetrated already. Root faces too small, it will happen. If it is root faces too small, the root gap too large. If you see the root gap too large, definitely root penetration bead in excess. Excessive amperage voltage, then definitely the root penetration will be more. Slow travel speed, because your slow travel speed is there, so melting metal, melting weld pool is more, so it will be the root will be penetrated more. So this fourth is very important. Root faces too small, root gap too large, excessive amperage voltage, slow travel speed. This four is the cause for the root penetration bead in excess. Now excessive root penetration, how it looks like. You see here, from here to here, this is excessive root penetration. This is, you can see the excessive root penetration. You cannot accept this holding. Excessive root concave RT images. You see, concave root, this is your images. You see the density has different from here to here. So the black shade is coming. So this is called concave root. And this is your excessive root penetration. So this is the dense. You see, your white area from here to here, this fog like that. This is your excessive root penetration. So you understand these two images, you have to compare that one, what is look like concave root, how it is look like in the radiography image, and excessive root penetration. So don't confuse. Burn through. What is burn through? A localized collapse of the weld pool due to excessive penetration resulting in a hole in the root run. Means a weld pool is there is a weld pool. When you are doing the welding, that weld pool, there is a excessive current has been generated in that weld pool, and it will be penetrated your parent metal and resulting a hole in the run. Means there is a root run, it will become hole, totally hole will become. So that is called the burn through. You understand here, this is the burn through. This is your process. You see here, this is your root welding when they are done. After that, this is burn through has been done. If the burn through has been done because of the excessive current, and the current is the excessive current, so parent metal, you can see parent metal how it is be melted, so that will be hole, hole will be generated here. What will happen? High amperage voltage, this is the main reason for the burn through. Small root face, if you see the root face is very small, so welder will be thinking there is not penetrate properly, so they will think that amperage will be more for this particular penetration need to be comes out. So when they will penetrate, current will be more, that time that will be band through will be appear. Third is large root gap. If you see the root gap is more, the very large, so definitely the band through will be there. Slow stable speed. So stable speed, if it is slow, definitely the weld metal will be weld full will be penetrated more. The band through could be occur. So these four things are very important for the cost for the burn through. So everything you have to maintain the as per WPS you have to follow. Not like high amperage, high voltage. So you have to follow the correct amperage, correct voltage to make the quality sound well. Now burn through RT images, how it looks like. You see the burn through. This is your burn through here to here. The parent metal already melted here. It's like a hole. You see here. Totally black images is coming from here. This is burn through. This is also burn through. So these two are the all the burn through images. Root caulking, oxidized root. You see root caulking, tea welding process. In tea welding process, this will happen. The root caulking oxidized root. Root is oxidized. Why it is happen? It's very important. Why it is happen root oxidized? Because loss or insufficient back purging gas. If it is back purging gas is not proper, so that area will be oxidized with the what is environment contamination, and that contamination will be oxidized with this metal, so the oxidation will be appear there like this way. So loss or insufficient back part gas. Secondly is most commonly occurs when welding stainless steel. Definitely stainless steel when will be you are welding the very important the purging gas. If it is purging gas less or more, then definitely will be oxidized or something defects will be appear. Purging gases includes argon, helium and occasionally nitrogen. So purging gases include argon, helium and occasionally nitrogen. So these three is the main reason. Now crater pipe. It is also very well known defect. Everybody knows when the which are uh, involved in those persons are involved in the welding inspection. You see the weld cutter. This is your cutter. This is your cutter pipe. So you have to know this one. What is the reason? Cutter pipe is a sinkage defect and not to a gas defect. So this is very important. Cutter pipe is a sinkage defect, not a gas defect. So it has the appearance of a gas pore in the weld cutter. You have to understand now. You are starting welding from here. Your weaving is like this way. In that area, cutter pipe, why it is generated? When it will be melted, that area, in that area, it will be sinkage will be there. And this area will be make a hole. That is called cutter pipe. And the what is the crack will be generated? Star cracks will be generated. You see 1, 2, 3, 4, 5. This type of cracks is called the star cracks. What is the reason? Too fast a cooling rate. If it is cooling rate is too fast, then it will be happen. So what need to be do? Cooling rate. So you need to do the preheat for this particular thickness of the weld metal or particular welding process. Deoxidation reaction and liquid to solid volume change. So deoxidation reaction can be happen and liquid to solid volume change. Contamination, if there is any contamination that can be created this cutter pipe. So these three things is very important. You have to know this one. Cutter pipe. Mechanical damage. This is everybody knows the mechanical damage can be defined as any surface material damage caused during the manufacturing process. So mechanical damage means when you are receiving the plate. So that can be damage, that also the mechanical damage. Also In the manufacturing process means you received a plate. After that, you are cutting the plate as per the drawing. At that time, you can see the grinding max is there. So that is called the mechanical damage. This can include damage caused by grinding, hammering. You are doing hammering because of you need hammering because of the fit up. Chiseling also you need for chiseling because of the fit up or final inspection. You need to chipping to clean that area, and you need to breaking up weld attachment. Definitely when you are doing the final inspection or final welding, definitely you have to do welding attachment or you have to remove. So all these things when you are doing, definitely that can be mechanical damage can be there. So what will be the action? Using needle guns to compress weld capping rents here. So what will be the action for that one? If you see the grinding, you have to remove that grinding by grinding, hammering, chiseling, all these things we have to check the one by one. If there is anything damage, we have to check the damage. How it will be checked? It can be known by welding inspector. Definitely, I am giving one example. If there is a, you can see the grinding marks. So you have to remove the grinding marks by grinding. After that, you have to check what is the thickness of this plate. That thickness it comes under the tolerance. So just that area is not a problem. If you see that it is not comes under tolerance, the thickness has been more, it is grinded. So definitely there will be problems. So it can not be accepted. So this is one example for mechanical damage. Setup irregularities. So irregularities, what is mean? Unequal leg length, a variation of leg length on a fillet weld. You can see here. You see here leg from here to here, from here to here, that leg length is not equal. Means inequality, a variation. You see here from leg length from here to here, from here to here, this leg length is not correct. So you cannot accept this weld. Unequal leg length on a fillet weld may be specified as a part of the design, in which case it will not be considered as a defect. Definitely, in some cases, if you see in the drawing, it is mentioned the unequal leg length, it is required for the particular area or as per the design, engineering drawing design. So that time it will not considered as a defect. But it is not mentioned anywhere in this unequal leg length, then definitely it will be a defect. Linear misalignment. You can understand here the linear misalignment how it looks like. You see here, this is your parent metal, this is your parent metal. So how it is, this is your line, but it comes up here. So this line, it is this two parent metal, it is not equally set up when the welder or fitter or fabricator done the fitting. So this is the reason, that's why I call linear misalignment is there. So it is coming from the starting of the plate. So before you have started the welding, you have to check this type of misalignment is there. You have to rectify, then you have to start the welding. So any questions is there? I have some questions for you people. So you people have to answer that questions. And if you cannot that answer, cannot find out any of the questions answer, then you can ask me. First question, give two main causes for the occurrence of a burn through. Already explained. Second question, give two main causes for the occurrence of excessive root penetration on a single bead weld. So you have already checked that excessive root penetration on single bead weld, what is the main cause? Every cause is mentioned in this video. Give 5 defects which may occur when welding carbon steel using the MMA welding process which current setting too low. If current setting too low, the what type of defect can be occurred? Question 4. Give 3 possible causes for the occurrence of lack of sidewall fusion. So what is the some causes you have find out for that lack of sidewall fusion? Question number 5. Case the following defect: lack of root wall fusion, lack of root penetration, incomplete field group, or concave root. This is very important. You have checked all images in this video, so you know very well lack of root wall fusion, how it looks like, lack of root penetration, incomplete field group, and the concave root. So this is the questions I have understands. If you not if you not get the answer for this particular question, so you can ask me in this comment box. So next is the material inspection. Material inspection, how you have to do the material inspection as inspected. All material arriving on site should be inspected for three things. One is size, dimensions, second is the condition, third is type specification. In addition, other elements may need to be considered depending on the material form or shape. So definitely material, when it comes at site, there is a form is there in every company. What need to be checked in that material? So that is the material inspection. If the minimum requirement is size and dimension, definitely it should be checked. It is as per the contract or as per the order. It is okay or not. Condition, which condition is there? Type or specification is mentioned in this plate or not. So these three things is very important. We have to check in the when a material is arriving on site. Parent, and after that we have to check the parent material defect. What is defect is there? If it is any defect is there, what will be happen? What will happen? So you have to check the parent material defects include mechanical damage, lamination, segregation line, lab. So segregation line, how we can find out? Lamination, how we can find out? Mechanical damage and lapping, how we can find out? So lamination are caused in the parent plate. Lamination, you can see here the parent plate inside there is a lamination by the steel making process. When the steel is making at the manufacturing, at the time the lamination has been created, originating from the ingot casting defect. So ingot casting defect. So this is ingot casting defects, that is called lamination. You can find out by UT. You have to check from the UT. Segregation bands occur in the center of the plate. You see center of the plate segregation band and are low melting point impurities such as sulfur and phosphorus. So this is segregation line. You have this is also parent metal defect. Laps are caused during rolling when overlapping metal does not fuse to the base metal. So you see lap. This means this some portion area from this area and this area is not lapping properly during rolling. So this is overlapping has been generated. That is called laps. So this is very important things. Mechanical damage, and mechanical damage is, do you know very well how it is happen in the manufacturing process, every manufacturing process. So plate lamination, you see here how it looks like the plate lamination. This is your plate lamination during the rolling. It is overlapping. It is not overlapped properly. That is lamination, plate lamination. So thanks for watching the video. I think up to that there is a part 3 will become in 1 or 2 days. I think you enjoyed this video. Thanks for watching the video. Please like, share and subscribe my channel to get the regular video. So thanks a lot and bye bye.